Okay, in this video, I will show you guys how to come up with an explicit formula and also a recursive formula for this sequence right here. And at the end of the video, I will also show you guys how to find the limit based on the explicit formula and also the recursive formula. I think for the recursive formula, it's really cool, so be sure you guys watch that. Okay, here we go. Notice that we have 3, 4, 5, 6, 7, and so on. Of course, we're just adding 1 each every time. And on the bottom, we're just adding 3 each every time, right? So we have an arithmetic sequence over another arithmetic sequence. For the explicit formula is the following. We will have an. Because the top rise, each every time we're just adding 1. That's a common difference, so the coefficient of n is just 1. Namely, we have 1n. But we have to add something so we can get to 3 for the first term. Well, when n is equal to 1, 1 times 1 is 1. We have to add 2 to get to 3. So we have 1n plus 2 for the top. And then for the bottom, well, each every time we're adding 3, so that will be the coefficient of n. And again, we have to think about something to add it here so we can get to the first term. Well, when n is 1, 3 times 1 is 3. We have to add 1 more to get to 4. So we have 3n plus 1 on the bottom. And guess what? That's it for the explicit formula, right? And to take the limit of this is just as fun. When you take the limit as n goes to infinity of this expression, namely n plus 2 over 3n plus 1. Well, all we care about is just n and 3n because they are the dominating parts on the top and also on the bottom. And when you divide, we get 1/3 for it. Very, very nice. And when the limit exists, we will say that an converges to this limit. Of course, we have the 1/3. So this is the language that we'll be using for the convergence of a sequence. Now, let's talk about how we can get to the recursive formula. Here is the deal. For recursive formula, we have to have a formula that's based on the previous term. Okay. Again, to get 7 over 16 from the previous term, we just add the 1 on the top and then we add a 3 on the bottom, right? So it seems like 6 over 13. We need to add 1 on the top and add 3 on the bottom like this. We put a plus in between and we say this is 7 over 16. Can we do that? We wish, right? If this is true, then everybody will be so happy, right? Unfortunately, this is not true. Please don't do this, of course, unless you put a circle around the plus, but don't do that either for this question. Anyway, unfortunately, this right here, it's not that easy, but here is the deal. Again, this right here is based on the previous term or sometimes the previous terms. Namely, we will have to come up with an minus 1. But anyway, let me just write this down right here for you guys in blue. We need a previous term, so let me just write this down right here. We need a sub n minus 1, namely the previous term. To get this, it's not that bad at all because we can just put the n minus 1 in here and here, and then we can work that out. So it looks like we will have 1 times this is sure that, so it's n minus 1, and we add 2 to it, over, we put this right here, so we have 3 times n minus 1, and then we add 1 to it. And of course, do some algebra real quick. This is an minus 1, and this is n plus 1, and on the bottom this is 3n. And then 3 times this is negative 3 plus 1, we get negative 2, like that. Now, here is the deal. We have a sub n minus 1 right here, and this is in terms of n. The truth is, we can solve for n right here. N can be written as an expression in terms of an. And when that happens, we can just plug in that expression into this n and that n. And keep in mind, they will be in terms of an minus 1. And therefore, we will end up with a recursive formula. So that's the strategy. And to make that happen, let's multiply this on both sides. So we will just get this right here. Let me put this times that, which is 3n times an minus 1. And this times that, which is minus 2. an minus 1. And this is going to be, of course, on the right hand side, we just have n plus 1, like this. And again, all we did is just multiply both sides by the denominator 3n minus 1. I mean 3n minus 2, like that. And now, our goal is to get the n by itself, n in terms of an minus 1. I'm going to just move this to the other side and move this to the other side. So we will see that when I move this to the other side, we have 2a sub n minus 1 and then plus 1. And when we move this to the other side, it becomes negative n. And this has n, that also has n. That's factor of the n. And then here we will have 3 times an minus 1 minus 1 because we need the minus n. And in the end, of course, we can just divide both sides by this, and we do get the n by itself, which is 2an minus 1 plus 1 over 3an minus 1 minus 1, like that. Very cool, huh? And now we'll just put this right here into this n and that n, and congratulations, we will have an based on an minus 1. So let's make that happen. I just put down this right here. Let me see, right here. Right here looks nicer. Yeah, let's put it on here. Now, okay, to do this, technically I will have to say a1 is equal to something. So let me just write down the format. 3 over 4. And then an is going to be something based on the previous term. And now let's work that out. Put this into n here and here. We see that an is equal to, this is just n, so we just write that down, which is going to be 2an minus 1 and then plus 1. And we add, well, we'll still have to divide, so we still divide this by that, which is 3an minus 1 minus 1, right? This is n right here, and then we add 2 to it. And we get like a complex fraction, okay? And then divided by 3 times n, which is now that, so we have 3 right here in the front, and we multiply by this guy, which is 2an minus 1 plus 1 over 3an minus 1 minus 1, like this. And then we are just going to add 1 right here, plus 1. That's 3n minus 1. Now we just have to simplify this a little bit and we'll be happy. This is a complex fraction, so let's go ahead and multiply the top and bottom by the common denominator, namely 3an minus 1 minus 1, 3an minus 1 minus 1. And now, let's see what will happen. Hopefully good things happens. Anyway, this times that, of course they cancel. We just have the top right here, namely 2an minus 1 plus 1. And this times that, of course, you have to distribute, so we see we get plus 6an minus 1 and then minus 2, like this. And then for the bottom, we have this times that, this and that will cancel, but don't forget to distribute the 3 and this, so we get, I'll put this down in blue, we get 6an minus 1 plus 3. 6an minus 1 plus 3. And just be really careful when you write down all the index and all that. Alright, so that's what we have. But we also have to do this times 1, which is just this, right? So we just add 3an minus 1 and then minus 1. And then we just pretty much continue. This is going to be this and that, which is 8an minus 1. This and that, which is minus 1, over this and that, which is 9, and then an minus 1. And this and that, of course, will be plus 2. So that's it. We simplify the an expression to be this. So that's very nice. And let me just maybe fit in here. So I'll see 8an minus 1 over 9an minus 1 plus 2. And this is true for n greater than or equal to 2, like this. So that's the idea. So that's a recursive formula. Very cool, in my opinion. Huh? Very cool. So that's it. Now, you might be wondering, what if one day somebody gives you this right here and asks you how to find the limit of the sequence? The answer to this is no longer this over that. It's not 8 over 9. Why not? Because we know the answer has to be 1/3 because we did that right here, right? Oh my god, how can we do the limit right here if we know an is equal to this? Again, in this expression here, you do not just take this over that and say the answer is a over 9. Don't do that. Now, here is the deal. Given that, right, suppose we know that this right here converges. So I will just say, suppose, right? Let's just say suppose. And in fact, for my homework question, I will give my students that given this right here, it does converge. So you don't have to do a lot of investigation. You don't have to show this is like decreasing and bounded or whatever. But anyway, I will just say, suppose an converges. And I'll tell you, suppose an converges to some number L. In that case, an minus 1 also converges to L. Right? So the idea is that then we can also say an minus 1 also converges to L. That's the idea. Then an minus 1 also converges to L. And here is the reason why. Remember, this right here is going to keep on going forever. And in the end, we are going to be getting about like 1/3, right? That's the limit. So imagine like right here, it's going to be a 1/3. But the previous term, wouldn't that be just about 1/3 as well? So that's the idea. If an is converging to L, then the previous term will also converge to L. So now, in order for us to utilize this, here is the deal. I will just write this down right here for you guys. I will just put this down. And I will just say as n goes to infinity, we will end up with the following. Now let's do like this. As n goes to infinity, this right here is what we are going to get. I'm just going to replace this with L. And then this and that, both with L. So we end up with L is equal to 8L minus 1, and then divided by 9L plus 2, like this. And congratulations, in fact, we just have to solve a quadratic formula right here. And congratulations, in fact, we just have to deal with a quadratic equation right here, because, of course, you can multiply this on both sides. So in that case, we get 9L squared, and then we have to plus 2L, and this is equal to 8L minus 1. And then, of course, you can just do this real quick. This is 9L squared minus 6L, and we add 1 to it, like that. This is equal to 0. And the truth is, we can factor this nicely. We get 3L minus 1 times 3L minus 1, which is 3L minus 1 squared. I know that, but it doesn't really matter because L is equal to positive 1/3. Cool, huh? Take a look. L is equal to positive 1/3. However, sometimes when you are doing this, you may end up with 2 factors, and most likely it's going to be 1 positive and 1 negative. In that case, you have to pay attention to how the sequence is behaving. Sometimes it's also depending on the first term when you are having recursive formula. So be really careful with that situation. But when I was doing the question for my students, I just do it like this, so there wouldn't be any confusion. So this right here is it. Oh my god, an also converges to L right here, which is 1/3. Alright, so let me know if you guys have any questions, and hopefully you guys all like this video. Thank you guys so much for watching, and as always, that's it.